Here we will discuss about exercise 2.3. So here are three formulas as power rule. What is power rule? If d over dx, any variable or function appears in power, this is power n. So what will be the solution and what will be the formula for this? This is n. So we will write n. This is x raised to the power n minus 1 and d over dx. Here we will write the function or variable on which there is power appearing. So here is power n on variable x, so here we will write x. So this will become nx n minus 1 and this will be dx over dx. So this will be equal to 1. So here this will be equal to nx raised to the power n minus 1. This is called power rule. So here we will apply on questions. So second is product rule. So here remember a thing that d over dx of x variable will be equal to 1. So derivative of x will be equal to 1. Similarly there is product rule. So what is product rule? If product means multiplication, so if there are two functions as f and second is g, so we want to find the derivative of this. So this will be equal to d over dx f and g. This will be f and derivative of second function g plus we will replace both of these, g and d over dx f. This is called product rule. So when we apply this rule, we will apply product rule when two functions are in the form of product or in the form of multiplication. So after that there is quotient rule. So what is quotient? Meaning of quotient is divide. So if two functions are in the form of divide, f divided by g, so here g will not be equal to 0. So this will be equal to g square, and we will simply write g function as it d over dx or derivative of f function minus we will write f as it and derivative of g function. So this is called quotient rule. When some variable is appearing in power, we will apply power rule, and some variables are appearing in the form of product, so we will apply product rule and quotient rule when our questions appear in form of numerator and denominator. So here we will do some questions related to this. So here is question number 1 of exercise 2.3. y is equal to x4 plus 2 x3 plus x square. So this is function y is a function of x, so we want to apply the derivation definition. So d over dx will be equal to d over dx x raised to the power 4 plus 2 x raised to the power 2 plus 3 and x square. So left side will be dy over dx and right side will be equal to d over dx x raised to the power 4 plus d over dx 2x raised to the power 3 plus d over dx x raised to the power 2. So here we will apply the formula of power rule. So this will be equal to, here if I apply power rule, so this will be equal to 4x raised to the power 4 minus 1 plus here we will take 2 and this will be d over dx x raised to the power 3 plus here we will apply power rule, so this will become 2 minus 1. So this will be equal to 4x raised to the power 3 plus 2. So here if I apply the formula, so this will become 3x raised to the power 3 minus 1 plus 2x. So this will be equal to 4x raised to the power 3 plus 3 2s are 6 x raised to the power 2 plus 2x. So this is formula and final answer of first question using power rule. So similarly we can find answer of the other questions. Now we will discuss question number 2, which is equal to y is equal to x raised to the power minus 3 plus 2x to the power minus 3 by 2 plus 3. So we will apply derivative here, d over dx y, and simply, so first of all we will apply derivative separately on three values. So derivative of minus x raised to the power minus 3, here is power, so we will apply power rule, and here is 2 x raised to the power minus 3 over 2, so we will take 2 as in start. So here is also power x raised to the power minus 3 over 2, so we will apply power rule, and derivative of constant is equal to 0. So here we know that by power rule, so power will be minus 3 and x raised to the power minus 1 plus 2, and similarly we will apply here power rule as x raised to the power minus 3 over 2. So here is power minus 0 to in start, and there will be minus 1 from the power. So after simplification, this will be minus 3x raised to the power minus 4, 2 will be cancelled out with 2, and this will be equal to minus 3 over 2 minus 1 will be equal to minus 5 over 2. So this is the x raised to we will take minus 3 as common, so this x raised to the power minus 4 will become positive 4 in denominator, and this power minus 5 over 2 will become plus 5 over 2 in denominator. So this is question number 3. So after question number 3 we will discuss question number 2. After we will discuss question number 3. Question number 3 is a plus x and a minus x. So we will take it as y, so derivative of y with respect to x, here will be d over dx a plus x over a minus x. So here we will apply quotient rule because these both of the value are in the form of division. So a minus x whole square and a minus x d over dx a plus x minus a plus x and d over dx a minus x. So derivative of constant is equal to 0, and derivative of x is equal to 1. So derivative of constant is 0, derivative of x is equal to 1, so this will be equal to minus 1 and this will be equal to 1. So here we will put the values, so this will be equal to dy over dx, so dy over dx will be equal to a minus x, and this will be equal to 1 minus a plus x, this value will be equal to minus 1 divided by a minus x whole square. So this will be a minus x, and minus minus will be plus, a plus x divided by a minus x whole square. So minus x plus x will be cancelled out, a plus a will be equal to 2a divided by a minus x whole square. So for this is final answer of question number 3. After question number 3 we will discuss question number 4. So if we take question number 4 is also about quotient rule. So y is equal to 2x minus 3 and 2x plus 1, so we will apply derivative on both sides. After derivative we will apply quotient rule, so this will become 2x plus 1 whole square and 2x plus 1 d over dx 2x minus 3, this is f and this is g function. So minus we will replace these two, 2x minus 3 d over dx 2x plus 1. So derivative of constant is equal to 0, derivative of x is equal to 1, so 1 will be multiplied with 2, so this will become a derivative of whole this value will be equal to 2, and similarly derivative of this value will be equal to 2 because derivative of constant is 0 and derivative of x is equal to 1, so 2 multiply 1 will be equal to 2. So this is derivative and this is derivative also. So this we will take 2 common here, so this will become 2x plus 1 and this minus will change the sign of these two values, so minus 2x plus 3. So plus 2x and minus 2x will be cancelled out, so this will become 1 plus 3 will be 4, 4 multiplied 2 will be 8 over 2x plus 1 whole square. So this is question number 4, exercise 2.5. After question number 4 we will discuss question number 5. So we know that about product rule. So here we can apply product rule because two functions are in the form of multiplication. So if two functions are in the form of multiplication, so we will write f d over dx g plus g d over dx f. This is called product rule. So here this is we can also apply product rule and we can also simplify. So after simplification we will multiply these two values. So this will become 3x minus x square minus 15 plus 5x. So writing x square in start, so minus x square plus 8x minus 15. So taking derivative and applying derivative separately like in question number 3. So this will become derivative of minus x square and derivative of 8x minus derivative of 15. This is constant, so derivative of constant will be equal to 0. Derivative of x will be equal to 1, so this will become 8, and derivative of minus x square, here we can apply power rule. So this will power in start, so we will take minus 1 from the power, so this will become minus 2x plus 8. This is derivative of question number 5. Similarly question number 6 is given as, this is simple question, but here is opening of the formula. So y is equal to square root x minus 1 over square root x square. So we will open this formula, a minus b whole square will be equal to a square plus b square minus 2ab. So a square plus b square minus 2ab. So square will be cancelled out with square. Similarly here, so this will become x plus 1 over x minus 2 because two values are cancelled out. So this will become x. Here in denominator power is 1. If x goes to numerator, so this plus power will become minus 1 and this will be minus 2. So we will apply derivative here on both sides and separating the derivative and applying on the single variable. So this will become d over dx x, derivative of x with respect to x is equal to 1. Here is power minus 1, so we will apply power rule. What is power rule? D over dx x raised to the power n is equal to n, this is power, and we will take minus 1 from the power. This is called power rule. So this will become minus 2. So here if x raised to the power minus 2, we will take it in denominator, so this will become positive power in denominator, so this will become x raised to the power 2. So this is question number 6. After question number 6 we will try question number 7. So if I write question number 7 here, so let y is equal to 1 plus k root x and x minus x raised to the power 3 over 2 divided by square root x. So here this is simple question. We can simplify this question as this is solution. So y is equal to 1 plus k root x and this is x minus, you can write x raised to the power 3 over 2 as x raised to the power 1 and x raised to the power 1 over 2 and divided by square root x, because we combined the both of these power, so this will become x raised to the power 3 over 2. So why we are going to separate these two powers? Because we can take x as power common, so this will become 1 plus square root x, and taking x here common, this will become 1 minus x raised to the power 1 over 2 divided by square root x. This is equal to y, and similarly y is equal to 1 plus square root x, and this is x, this will become 1 minus, we can write it as in the radical form square root x divided by square root x. So here y is equal to 1 plus square root x and 1 minus square root x and simple value of x divided by square root x. So further this will be equal to y is equal to, we can combine this as in the form of formula. So this will become a square minus b square and this is equal to, we can write simple x as square root x multiply square root x, because square root x multiply square root x will be equal to value of x. So we can replace x as square root x multiply square root x. So I will write square root x and square root x divided by square root x. So 1 square root x will be cancelled, and square root will be cancelled, so y will be equal to 1 minus x and square root x. So y will be equal to square root x after multiplication and minus square root x and x raised to the power 1. So this will become y is equal to square root x minus, this is x raised to the power 1 over 2 and this is power 1. So power 1 and 1 over 2 is equal to power 3 over 2. So we will write x raised to the power 1 over 2 minus x raised to the power 3 over 2. So here we will apply derivative dy over dx on both sides. So d over dx, x raised to the power 1 over 2 minus d over dx, x raised to the power 3 over 2. So here both of the values are in the form of power, so we can apply power rule here. So we will write power in start and x raised to the power 1 over 2 minus 1, similarly minus, and this will be equal to 3 over 2 power in start and 1 minus from the power. So this will be equal to 1 over 2 x raised to the power minus 1 over 2 minus 3 over 2 x raised to the power 1 over 2. So this is final answer, or we can take here as 1 over 2 as common. So this will become 1 over square root x, because this is power 1 over 2 in denominator, this power will become positive. So minus 3 square root, this can also be the answer of question number 7. After question number 7 there is question number 8. So this is also simple question. So here is y is equal to x square plus 1 square divided by x square minus 1. So we know that if two values are in the form of numerator and denominator divide form, so we will apply quotient rule. So this is f and this value is g, so we will apply quotient rule here. So after quotient rule, this will become this is g square, this is g, this is f derivative, and this is f function, and this is g. So we applied quotient rule. So here derivative of x square plus 1 square, so this is in the form of power, so we will apply power rule on this portion. Power is in start, and we will take minus 1 from the power, and derivative of the expression on which power is appearing. Power is appearing on x square plus 1, so derivative of x square plus 1, and derivative of x square minus 1 will be equal to derivative of constant is 0, and derivative of x square we had read in previous questions. So derivative of x square will be equal to 2x. So final answer of this expression will be 2x. So x square minus 1 and derivative of this expression is 2x square plus 1, this will become 2 minus 1, and derivative of this expression will be equal to 2x. So we had write 2x here minus x square plus 1 square, and this is 2x. So we will take 2x as common, and x square plus 1 we will take this portion common from this whole value. So this will become 2x square minus 2 minus x square minus 1, and after simplification this will become minus 2 minus 1 will be equal to minus 3, and 2x square minus x square will become x square. So this is answer of question number 8. So after question number 8 we are going to discuss question number 9. So what is question number 9? So this is question number 9, written as x square plus 1 over x square minus 3. This is same as question number 8. We will simply apply quotient rule here. So this is f and this is g function. So we can apply here quotient rule. So this is g, we will change the color. This is g square, this is g, this is derivative of f, this is g, this is f, and this is derivative of g. So simply derivative of x square plus 1 is equal to 2x. We had discussed earlier. Derivative of x square minus 3 will be equal to 2x, because derivative of constant is equal to 0. So this will be we will take 2x as common from this expression. So this will become x square minus 3 minus x square minus 1. So x square positive and x square minus will be cancel out. So this will become 2x minus 4. So the final answer of this question will be minus 8x. So after question number 9 we will discuss question number 10. So question number 10, question number 12 and question number 13 are same. So here is square root 1 plus x, square root 1 minus x. So we will combine the square root and take radical form into the exponential form. So when questions appears in the form of power or exponent, we will apply a power rule. So here we will apply power rule. Power, we will write power in the start, or we will take minus 1 from the power and derivative of the expression on which power is appearing. So this portion says about quotient rule because there are two values in the form of division, so we will apply here quotient rule. So this is g square, this is g f, and this is f, and this is g. So we will apply quotient rule on this portion, and derivative of 1 is 0 and derivative of x is equal to 1. So this will be equal to 1. This similarly derivative of 1 is equal to 0, and this will be minus, and derivative of x is equal to 1. So after simplification, positive x and minus x will be cancelled out. So this will become 1 plus 1 will be equal to 2. 2 will be cancelled out with 2. So on the next step we will combine 1 minus x and 1 minus x and 1 plus x. So this is power 1 plus x having power 1 minus 1 over 2. On denominator 1 plus x will have power plus 1 over 2. So this 1 minus x has power minus 1 over 2, and 1 minus x has power 2. So if we combine these two power, so this will become minus 1 over 2 plus 2. So this will be equal to positive 3 over 2. So this is final answer of the question. We can write 1 plus x square root power 1 over 2 in the form of square root in the radical form. So after question number 10 we will discuss about question number 11. So if we write question number 11 as into the form of, so after question number 10 we will do question number 11. So here we will also apply quotient rule first. This is first function f and this is g. So we will take derivative with respect to x, dy over dx and d over dx, 2x minus 1, and this will be equal to x square plus 1 power 1 over 2. So here we will apply quotient. So this will be equal to x square plus 1 power 1 over 2 square, and we will write x square plus 1 over 2 derivative of d over dx 2x minus 1, and this will be minus 2x minus 1 and d over dx x square plus 1 power 1 over 2. So this will be equal to x square plus 1 power 1 over 2. In denominator this will be cancelled out, so this will be simply equal to x square plus 1. So this derivative of 2x minus 1 will is constant, derivative of constant will be equal to 0. So x derivative of x is equal to 1. So 1 multiplied with 2 will be equal to 2 minus 2x minus 1. Here we will apply quotient power rule. So this will become 1 over 2 power in start, and x square plus 1 over 2 minus 1, and again derivative of x square plus 1. So in next step we will simply write derivative of x square plus 1, which will be equal to 2x. So this expression of dy over dx will be equal to x square plus 1 raised to the power 1 over 2 and 2 minus 2x minus 1. So this will become 1 over 2 x square plus 1, and 1 over 2 minus 1 will be equal to minus 1 over 2, and derivative of x square plus 1 will be equal to 2x divided by x square plus 1. So after that if we simplify this question, so this will become dy over dx will be equal to 2 x square plus 1 power 1 over 2, and 2 will be cancelled out with 2. So this will become minus 2x minus 1 and x square plus 1 raised to the power minus 1 over 2, and x divided by x square plus 1. So this is final expression. So here we will write 1 over x square plus 1, and if we simplify these two expressions, so we can write it as 2 x square plus 1 raised to the power 1 over 2 minus this will become 2x minus 1, and this is power minus 1 over 2, so in denominator this will become x square plus 1 minus 1 over 2, positive 1 over 2, and value of x. So here we can take in next step we can explore this question to the next step, x square plus 1. So derivative will be x, LCM will be equal to x plus 1 raised to the power 1 over 2. So this expression will become x square plus 1 raised to the power 1 over 2 multiply with 2 minus 2x minus 1 and x. So after simplification this will be final answer. Dy over dx will be equal to 1 over x square plus 1, and this will be 2 x square plus 1 minus 2x square minus x divided by x square plus 1 raised to the power 1 over 2. So if we combine x square plus 1 and x square plus 1 power 1 over 2, so this will become in denominator x square plus 1 plus this is power 1, and 1 plus 1 over 2 will be equal to 3 over 2, and similarly this will be equal to 2x square plus 2 minus 2x square minus x. This will be cancelled out, so final answer of this question will be equal to 2 minus x and x square plus 1 raised to the power 3 over 2. So this minus will applied, we will apply this minus 1 minus 2x, so this expression will be positive. So this is positive x, and this is final answer of question number 11. So after question number 11 we will do question number 12. So we had discussed earlier that question number 11, 12 and 13 are same questions. So here is question number 12. So here y is equal to square root a minus x and a plus x. We will combine the square root and we will convert a radical form into the exponential form, and on exponential we will apply power rule after derivation. So 1 over 2 is power in start, and 1 over 2 this is power rule. So we will take minus 1 from the power, and again derivative of the expression on which power is appearing. So here on this value we will apply quotient rule because this is in the form of divided. So this value will be same, and we will simply solve this portion of the question. So here we had applied quotient rule. So derivative of a will be 0, derivative of x will be equal to 1, so this expression will be minus 1 and this will be positive 1. So x positive x and minus x will be cancelled out. So minus a and minus a will be equal to minus 2a, 2 will be cancelled out with 2. So this is final expression. Here we will change, this is power minus 1 over 2, and denominator this will become positive 1 over 2, and this is power minus 1 over 2, and this is power 2, a plus x and a plus x. We will combine these two powers, so this will become 3 over 2. This is final answer of the question number 12. After question number 12 we will discuss about question number 13. This is the same question as we had discussed earlier in question number 10, 12, and this is again question number 13. We will combine the square root and convert into the radical exponential form. We will apply power rule here. So after applying power rule, this will expression 1 over 2 power minus 1 and derivative of the expression on which power is appearing. So here this is form of f divided by g, so we will apply quotient rule here. So derivative of 2x plus square plus 1 will be equal to 2x, and derivative of x square minus 1 will be equal to 2x. So after putting these value and taking 2x common here, so x square minus x square will be cancelled out, minus 1 will be equal to minus 2, so 2 again will be cancelled out with 2. So again we will separate x square plus 1 power minus 1 over 2, and we will take this power in denominator. Here is minus power, and in denominator this will become positive, and this is power minus 1 over 2, and this is power 2. Combining these two powers, this will become 2 minus 1 over 2, and this will be 3 over 2. This is question number 13. After question number 13 we will discuss about question number 14. This is some change question. So here are the expression. We will rationalize this expression. Here is positive sign, we will take minus here in upward and numerator and denominator. So this will become a minus b whole square, and a square plus b square minus 2ab, and this will become a square minus b square, and square root will be cancelled out. This will become plus 1 and minus 1 will also be cancelled out. So here square and square root will be cancelled out. So we will combine these two square roots. This will become a plus x and a minus x, or 1 plus x 1 minus x. So here we will take 2 common, so this will become 1 minus x square power 1 over 2 divided by x. So here this is the f function and divided by g function. So we will apply quotient rule here. So after applying quotient rule, this is square of the denominator function x, derivative of this whole expression minus this whole expression, and derivative of x. Derivative of x will be equal to 1. So here is x same, derivative of 1 will be equal to 0. Here on this expression, because there is power 1 over 2, we will apply power rule. Power in start, we will take minus 1 from the power, and again derivative of the expression on which power was appearing. Power was appearing on the 1 minus x square, and this expression we will write the same. So here after simplification of this expression, 1 over 2 minus 1 will be equal to minus 1 over 2, derivative of 1 is equal to 0, derivative of x square is equal to 2x, so this will become minus 2x. So 2 will be cancelled out with 2, so this expression will become in this form. So this is power positive here. In last expression this was minus power, so in denominator this power will become positive. So minus 1 plus power 1 over 2. So on next step we will take the LCM of this expression. So this is the simple value here, 1 over 2 plus 1 over 2, because this will become square. So 1 over 2 plus 1 over 2 will be equal to 1. So positive x and minus x will be cancelled out. This is final answer of the question number 14. So after question number 14 we will discuss question number 15, 16 and 17 and at end of the exercise. So here is some typical question, or you can say that this is important question. We can say that y is equal to x square root a plus x square root a minus x. We will combine the square root and we will convert the square root into the exponential form. This kind of question we had done earlier in previous questions of the same exercise. So here two functions are in the form of multiplication or product. We will apply product rule here. First function derivative of second function plus second function derivative of first function. So here we will simply solve this portion separately as we had discussed earlier. So we will apply here power rule, power 1 over 2 minus 1, derivative of the expression on which power was appearing. So here on this expression we will apply quotient rule, a minus x derivative of a plus x minus a plus x derivative of a minus x divided by a minus x whole square. So derivative of a plus x will be equal to 1, derivative of a minus x will be equal to minus 1. So after simplification this expression will be minus x plus x cancel, a plus a will be equal to 2a, 2 will be cancelled out with 2. So this is the answer of this expression. So if we discuss further, so this will become derivative of a plus x a minus x power 1 over 2 is equal to this expression. So we will put this in equation 1. This is equation number 1 here. So this will become x, and we had put the value of this expression here plus the same expression. So we will multiply x, this will become xa and same expression plus a plus x power 1 over 2 a minus x power 1 over 2. So after taking the LCM, So this expression will become simple into the form of a plus x a minus x, and we will apply the formula a square minus b square. So this is the final answer of question number 15. Now we will discuss question 16. So y is equal to, in the exponential form, x raised to the power 1 over 2, and this will become y is equal to minus x raised to the power minus 1 over 2. So we will apply simply derivative here. So this will become dy over dx and d over dx, x raised to the power 1 over 2 minus d over dx, x raised to the power minus 1 over 2. Here we will apply power rules. This will become 1 over 2 x raised to the power 1 over 2 minus 1 minus, this will become minus 1 over 2, again power rule, x raised to the power minus 1 over 2 minus 1, this will become 1 over 2 x raised to the power minus 1 over 2 minus minus plus 1 over 2 x raised to the power minus 3 over 2. So this will become 1 over 2 as common, x raised to the power minus 1 over 2 plus x raised to the power minus 3 over 2. This is dy over dx. On next we will multiply this expression with 2x. So by multiplication this expression with 2x, this will become 2x dy over dx. Similarly on right side 2x, 1 over 2 x raised to the power minus 1 over 2 plus x raised to the power minus 3 over 2. So this will be equal to 2x, 2 will be cancelled out with 2, and x multiplied with these two expressions, this will become x raised to the power 1 x raised to the power minus 1 over 2 positive, x raised to the power 1 x raised to the power minus 3 over 2. So this will become x raised to the power 1 minus 1 over 2 plus x raised to the power 1 minus 3 over 2. This will become x raised to the power 1 over 2 plus x raised to the power minus 1 over 2. This is dx dy over dx. Again we will add y on both sides, 2x dy over dx plus y. So this will become x raised to the power 1 over 2 plus x raised to the power minus 1 over 2 plus y. Again put the value of y is equal to x raised to the power 1 over 2 and y x raised to the power minus 1 over 2. So this will become 2x dy over dx plus y will be equal to x raised to the power 1 over 2 plus x raised to the power minus 1 over 2 plus x raised to the power 1 over 2 minus x raised to the power minus 1 over 2. This will be cancelled out. So this is x raised to the power 1 over 2 and 1 over 2. This will become 2 x raised to the power 1 over 2, which will be equal to square root x. This is proof of the question number 16. This is the last question of the exercise 2.3. So we will take derivative of y dy over dx with respect to x, d over dx, x raised to the power 4 plus d over dx, 2x raised to the power 2 plus d over dx 2. So here applying power rule, this will become 4x raised to the power 4 minus 3 plus 2 taking as common d over dx, x raised to the power 2 plus derivative of 2 constant will be equal to 0. This will be 4x to the power 3 plus 2 derivative of x square will be equal to 2x dy over dx. This will become dy over dx is equal to 4x raised to the power 3 plus 4x, taking 4x common, this will become x square plus 1 dy over dx. So this is the proof 4x, and we will convert this expression into the y form. So this will, we know that y is equal to x4 plus 2x2 plus 2. So here is y minus 1, so take minus 1 from both sides, plus 2x2 plus 2 minus 1. So 2 minus 1 will be equal to x raised to the power 4 plus 2x to the 2 plus 1. This will be x square plus 1 square plus 2a and b. This will become x square plus 1 whole square and y minus 1. Taken square root on both sides, square and square root cancel. Square root y minus 1 will be x square plus 1. So this is equation 1. Put in 1, so this will become dy over dx is equal to 4x. This expression is equal to square root y minus 1. This is proof of this expression.